So let's recap what we learned from the last example. We were finding intervals of increasing, decreasing. So our first step is to find the critical numbers of f. If you look back at our example from the last video, that's exactly what we did. And then determine the sign of our derivative, f prime of x, at one test value in each interval. All right, so the next thing we're going to do is talk about the first derivative test. So I'm going to write what it says, and then we'll have a picture that kind of goes along to help us visualize. If f prime of x changes from negative to positive at c, then f has a relative minimum at the point c f of c. Part 2 tells me if f prime of x changes from positive to negative at c, then f has a relative maximum at c f of c. And then the third part says if f prime of x is positive on both sides of c, or negative on both sides of c, then f of c is neither a relative max nor a relative min. So I kind of want to give you a picture here of what's going on just so you can visualize. So let's say I want to draw a function that has a relative max and a relative min. So let's say my function looks something like this. So let's look at part 1 of this first derivative test. It tells you if your derivative changes from negative to positive, so if your function is decreasing and then it switches to increasing, it tells us that this is a relative minimum. And that's exactly what happens at this relative minimum. Your function is decreasing down and then switches to increasing up. If you look at part 2, if the derivative changes from positive to negative, so if your function is increasing, the derivative's positive, and then it's decreasing, the derivative's negative, this corresponds to a relative max. All right, so now that we have that, let's see if we can look at a problem here where we're trying to find the relative maxes and mins. Find the relative extrema of my function 1/2 x minus sine x in the interval 0 to 2 pi. So the first thing I'm going to do is find my derivative. 1/2 minus cosine x, and we're going to find our critical numbers. So if I solve for this equation, I'm going to get cosine of x equals 1/2. So there are two angles on the unit circle where cosine is 1/2, pi over 3 and 5 pi over 3. So I'm going to make my number line here, and we're going to start off at 0 and end at 2 pi. That's my interval looking at, and I'm going to put pi over 3 on here and 5 pi over 3. And if you look, you're going to have 3 subintervals here. 1, 2, and 3. So you need to pick a test point in each one of those. So let's go back here. Let's pick pi over 4. Let's pick between pi over 3 and 5 pi over 3. Let's pick pi. And then let's pick 7 pi over 4. And we're going to go to our derivative, plug these test points in. F prime of pi over 4. It's 1/2 minus cosine pi over 4. 1/2 minus square root of 2 over 2. So the numerator here, square root of 2 is bigger than 1, so that's negative over a positive. So this will be a negative. If I plug in pi, get 1/2 minus cosine pi. Cosine of pi is -1, so it'll become a positive 1, and that is positive. Last one we need to plug in, 7 pi over 4. 1/2 minus cosine of 7 pi over 4. 1/2 minus square root of 2 over 2. It's the same as what you got for pi over 4. So this will have a negative here. So now I want to decide what are my relative extrema. So think about it in terms of your chart. Here my function was decreasing, and then it switched to increasing. So what kind of extrema do I have there? I have a minimum at pi over 3. So we have a relative minimum at x equals pi over 3. And let's look over here. My function was increasing, but then it switched to decreasing. So that means I have to have a relative maximum. I have a peak or a highest point. So you have relative maximum at 5 pi over 3. So those are my relative extremum.